Hello, everyone. Welcome to our fourth day of the Kaggle Generative AI Intensive course, where we have been teaching over 250,000 of you developers out into the world all the things that you would ever want to know about generative AI and how to use it as part of your projects. I am so excited to be here today with our expert panel of guests and all of the folks who are around Google, Google DeepMind, Google Cloud, Kaggle, all sorts of places in Alphabet who have come together to build this course and to make it a reality. So just as a general reminder, this course is a 5-day generative AI intensive sponsored by Kaggle. It includes daily assignments, things like Discord discussions, as well as codelabs. We are on our 4th day of the course, which is focused on domain-specific large language models. So showing how you can fine-tune models to meet the needs of your projects. And I want to give a huge virtual round of applause and thank you to our wonderful Gen AI course moderators. They have been working tirelessly around the clock to answer your questions, to make things perfect for our code labs. And I just want to make sure that they all get recognized. So thank you so much to everyone, especially our ops team, Brenda Flynn and Kinjal Parekh, who have been tirelessly, again, just pushing through to make this happen and giving a lot of love to the course. So with that, I am going to hand it over to Anant, who is going to give a brief curriculum overview of all of the white papers that y'all have been reading over the last few days.
Thank you, Paige. So hi, everyone. So welcome to day 4. So in my curriculum overview, I'll just start off by mentioning what we have done last few days. For instance, in day 1, we looked at how foundational models take and various topics such as techniques to tune them, make them run efficiently, as well as prompt engineering to get the desired outcome. Then in day 2, we looked at how data can be embedded in their semantic representations and search for at scale using vector databases. And then in day 3, yesterday, we looked at how all of this can be combined and extended to make agents, which can dynamically make decisions and interact with the external worlds in order to achieve their objective. Now, today in day 4, we are going to look at how all of these concepts that we learned in the previous days can come together and being used to make specialized domain-specific models. So let's get to a recap of the white paper for today. So first, we read in the white paper that general LLMs often need specialization for fields like cybersecurity and medicine, as well as more. These areas have unique data challenges, technical language, as well as sensitive requirements that demand this adaptation or can benefit from it. Then we started off with the cybersecurity example with SecLM. It tackles evolving threats, analyst toil, and talent shortages by combining specialized models, threat intelligence, as well as automated reasoning to assist security professionals. Training involves adding security data and fine-tuning on relevant tasks and some more. Then we looked at the section on medicine, which features MedLM and MedPalm. These models address the challenges of navigating vast medical knowledge for tasks like high-quality medical Q&A and supporting clinical workflows. MedPalm 2, for instance, showed expert-level performance on medical exam benchmarks. A key to this field is rigorous evaluation, and we read about this, for instance, using specific benchmarks and expert clinician reviews, plus careful, phased, real-world testing as well. Now, training involves instruction fine-tuning on medical data and advanced prompting strategies for these two models. The white papers then basically, towards the end, concluded that with the fact that successfully deploying these powerful tools requires not just specialized models, but also deep collaboration with domain experts and thorough step-by-step evaluation to ensure safety and effectiveness in these critical fields. So that would be the summary of what you read in today's white paper, and off to you, Paige, for the Q&A.
Amazing. And that is super exciting. I loved learning all about how we can fine-tune models and make them great for things like cybersecurity and things like healthcare. And with that, we're going to go in our Q&A session. So I am overjoyed today to welcome Scott, Chris, Karthik, Eva, and Donnie to talk about the work that they're doing around Google Research, Google DeepMind, and Google Cloud, and to tell us a little bit more about these fascinating topics. And all about fine-tuning and how to make it real in production environments. So welcome so much today. For our first question, Donnie, this is for you. From a research and engineering perspective, what are the most effective strategies for specializing LLMs? Is it better to fine-tune large general purpose models to train smaller models from scratch on domain data, or use techniques like parameter efficient fine-tuning? Do these choices kind of impact performance, cost, and how do you keep the models updated over time? So lots of questions embedded into a single one. Do you want to take that?
Thanks so much, Paige. So what we found over time, especially in our experience with building MedPalm and MedLM, is that there isn't one best way to specialize a large language model for a task, and that the best method really depends on the nature of the task, the complexity of the task, and of course, like the amount and quality and the nature of the data that you have available to you. The best way to figure out which method works best is, well, first of all, you can look at similar problems, other things people have tried, things in the literature, and see if any of those are a good fit, and then try that first. But ultimately, you really just have to experiment and see what works best. You have to test different methods and see what works well. Of course, the less compute that you need to achieve your goals, the better, right? That allows you to control your costs. That also allows you to keep your, gives you the ability to keep your model better updated if it's cheap to retrain. But some complex use cases will require regular updates of new data, and so you'll have to be training regularly to keep that model updated. So that affects the updatability as well. Thanks for the question.
Awesome. And I know that I often have seen people ask unfine-tuned models, so just the Gemini models or others like it, medical questions, or things that are similar to healthcare and grounding on PDF documents or other kinds of data. Would you recommend that people always start with kind of prompting the unfine-tuned model before diving into fine-tuning their own?
It's always good to see what the base capability of the foundation models are. I think in specialized domains, I think you'll find quickly that there are going to be limitations, especially if you're thinking about about deployments, especially in clinical scenarios, that you're going to test the foundation models. They're going to be very good at many tasks, but there's going to be specialization that you're going to find once you kind of hit the edges of what the foundation models are capable of. There are, of course, use cases where the foundation models are going to do very well, and that will that can be the end of it, and you can use those in your applications.
Yep, I love being able to kind of turn all of these knobs and dials to get a model that's really compelling for a business use case, and that we have this flexible series of approaches across just using models out of the box and then also customizing them for user needs. So that's very cool. Thank you so much for your answer. Our next question is a community question from Yuvan Thiran. During the fine-tuning code lab, I observed significant token savings. However, there are scenarios where fine-tuning can unintentionally reduce the generality or creativity of a model? And how do teams evaluate when to fine-tune versus when to use prompts or retrieval? So very related to the last question that we were discussing. Chris, do you want to talk about this one?
Yeah, sure. I think this is a great question, and there's definitely problems that you're going to encounter when you start fine tuning. Especially, there's a problem that you'll probably hear commonly referred to as catastrophic forgetting, which is sort of kind of the worst case scenario you encounter when you're fine tuning, where you've gone too far and the model can't do other things anymore. It's only able to do kind of the very specific task that you fine tuned on. And there's, of course, kind of a gradient in between the foundation model and the kind of worst case scenario I just described. But especially when you're fine tuning, it's really important to have a thorough evaluation around a range of tasks that you're going to be doing. Not just the task you're necessarily fine tuning, but what other possible scenarios you're going to be using it in, so you can understand kind of the quality, either gains or losses, depending on how you've been fine tuning on those sort of adjacent tasks. Generally, when we're doing this in security use cases, we aim for a range of evaluation tasks and also a range of fine-tuning tasks. So we want to teach it general concepts during fine-tuning, and then be able to sort of use the generality of those concepts again at deployment time or at runtime. It gives us kind of a mix of both, but really evaluation, and I think you're going to hear this in a few different areas this morning, but evaluation is key in a lot of these kind of domain-specific areas.
Awesome. And Scott, did you want to add something?
Yeah, absolutely. So just to build on sort of Donnie and Chris's answer here, I always go back to, I know this, maybe this is like not the cool thing to do, but I always go back to like the first principles of like ML, right? So does the model, is the task that I'm doing in distribution for the model, was it trained on the thing and on the data that I expected to operate on? I think that's really the key question when it comes to fine tuning and which level of fine tuning, whether it's full parameter fine tuning or something that's parameter efficient like LoRa or other methods. So I think one thing you'll find is a really great paper out there called the reversal curse. It kind of starts talking a little bit about where in this stack of training you can start to actually get really good generalizable knowledge. And sort of the further down you go from, pre-training through fine tuning through alignment and now into, parameter efficient techniques, like the less and less generalizability you get and the more like forgetting you tend to get. And the more, honestly, the more in distribution your task has to be in order for it to be successful. So I think that's one of the big questions to really think about when you're talking about kind of like, to what degree do I need to fine tune, is really like, well, do I already expect this to be in the training data somehow? And if so, then maybe I don't need to do that much to just nudge the model a little bit in the direction that I want it to go. And if not, then probably something more significant is going to be necessary, and we'll have to do that more carefully to not forget some of the baseline capabilities.
Amazing, and we'll put a link to that paper that you recommended into the YouTube video and some of the notes for the course as well. I love that answer. Excellent, thank y'all. This is a great start for our Q&A. Next question, also for Chris. So when developing LLMs for security domains like SecLM, what are the biggest challenges in acquiring and using relevant, high-quality data for fine-tuning, given its sensitive or proprietary nature? How do you measure success and ensure these models improve security operations without introducing new risks? So it's a very evals-heavy discussion this morning.
Yeah, definitely. I think that's great, though. So we know that providing accurate and useful security advice is really hard. There's a lot of conflicting opinions online. Everybody has sort of different ways of approaching security. And it's also something that really needs to take the kind of environment and situation into account. Thinking about people at home, and email security is very different than thinking about code security and other sort of tasks. And so we do need to kind of sort of have different kinds of data sets for different kinds of tasks. And oftentimes those data sets are proprietary or sensitive in some way. So what we've sort of done with building SecLM is have a chance to experiment with that whole spectrum. So everything from training and fine tuning on models where we are using heavily, large amounts of internal information about security and threat actors and sensitive material there, all the way to the kind of the other end of the spectrum, using basically foundation models more or less off the shelf. And that gives us a really sort of nice spectrum to sort of pick a place to work. And so what we've seen is that the best performing approach for us is kind of sort of in the middle, where we're doing training with plenty of high quality public security information. And that's really feeding into the foundation models, into Gemini itself in this case. And then we layer on runtime techniques like RAG. That doesn't mean we don't need fine tuning. We do think about fine tuning absolutely as how to make these tasks perform well, but we tend to fine tune in a way where we're looking at sort of understanding a generalized task rather than maybe memorizing specific information. So it's not about necessarily the recall given, the recall against a specific threat actor or other sort of piece of material, but being able to converse and answer questions accurately, giving the grounding material about that particular actor in that situation. The kind of other element of sort of coupling these training, fine tuning, and runtime techniques gives us a really nice way to also give our users other sorts of benefits. So features like citations provide a lot of user confidence in sort of what the model is telling them. If we give people advice in a security direction, you should change your password so and so often, it's really great to be able to point to a policy, a document, research, other things that kind of vouch for that particular statement. And so that's one way that we do this. And of course, evaluation on this again is key. So evaluating with that grounding material, without the grounding material, all of that sort of thing, you're going to build out really good evaluation data sets for understanding really just how good you are at the different security specific tasks with and without that proprietary information.
And that's a great answer. And for folks who are curious about evals, the next day is going to be discussing them in depth. So make sure to tune in tomorrow as well for more discussion about evals. I also really love citations. I use them all the time, both when grounding with Google search. So being able to see kind of the up-to-date and relevant information that the model is using to help ground its outputs, as well as grounding on internal data sources. I love being able to kind of click and get to a PDF document or something similar to get more confidence in the model's answer. Awesome. Next question. This is for Eva. Healthcare and life sciences is a domain with complex terminology, high stakes for accuracy, and significant regulatory considerations. What unique challenges and opportunities arise when building or fine-tuning large language models for these healthcare applications? And how do you ensure that the model is reliable, that it has high safety, and also compliance?
Thank you, Paige. So we've been hearing a lot about the challenges. So why even do domain-specific LLMs? So let me start with the potential. I think that the potential is immense. Think about personalized medicine. Think about scientific discovery, improved clinical documentation, more effective healthcare processes. There is so much potential that building those LLMs brings. And hopefully many of you are looking at how we can bring this technology into the space of healthcare and life sciences. The challenges, unfortunately, are still pretty hard and unique. Complex domain-specific terminology. If you think about how two doctors talk to each other, none of us could understand that. And the LLMs need to be able to actually understand that new terminology. High accuracy demands. This is actually a life and death situation in many cases. Evolving knowledge landscape, the science, both the medical science and the life sciences evolve and new discoveries come up every day. So the stale information becomes inaccurate. There is data scarcity, need for causal reasoning, and really stringent regulations. So the opportunities lie in automating tasks, accelerating research, and improving patient interactions. It's really important to ensure reliability, safety, and compliance. And in order to do that, we use a multifaceted approach. This includes curated data with strong governance, rigorous model evaluation with specific metrics, and expert validations. We're prioritizing explainability, implementing robust safety measures against harmful content and biases, and adhering to all regulatory requirements. There is a necessity for interdisciplinary collaboration and continuous monitoring. So not just at training time and fine-tuning time, but you want to continue monitoring the systems after deployment.
Awesome. That's a lot of wonderful things to consider when building these healthcare and life sciences AI systems. So thank you for going into depth for all of the things that engineers might want to be mindful of. Next question is for Karthik. Welcome to the call. How do you balance the need for deep domain expertise within the model against the risk of things like catastrophic forgetting, which we heard about a little bit earlier, or overfitting on specific training data? Are techniques like RAG or using the context window sometimes a better alternative or a complement to fine-tuning for domain adaptation?
Thank you for the question. That's a really great question. I think let me answer that in two parts. Let's start with the first part, right? Some of this was discussed by Donnie and Scott and Chris in like the first set of answers, right? I think there are some very important practical considerations when you make some of these choices, and it depends on how you plan to use the final model. What is the domain and specific applications of this model? If your goal is a very specific, very narrow task that you don't run the risk of sort of needing a lot of general purpose knowledge, it is okay to sort of go with a more heavy-handed fine-tuning approach per se, because there usually isn't too much in terms of a trade-off outside of computation budget. But a lot of tasks that do need more open-ended, more knowledge-heavy tasks do sort of need a more gentle, measured touch, because you do really want to sort of make sure the model is not losing some of the general purpose knowledge. Because again, as already we discussed, the more you fine tune, the risk you run of sort of losing some of that knowledge. So I think there also is a consideration in terms of the out-of-box skills for the base LLM on the specific domain or application. A domain that is more commonly represented, say perhaps in the pre-training data, is going to be something which is better. Models are going to be better at, say, something like code than they would at, if I ask you something, a very esoteric domain per se, I don't know, nuclear physics or something like that. So I think that is another consideration when you're sort of trying to determine this, how common, popular, how good are the out-of-box skills of the base model before you sort of try to sort of go further down the fine-tuning route. In recent years, I think the LLMs have advanced enough that the pendulum has swung a lot more towards light touches, parameter-efficient fine-tuning, just because, again, the base models have become much more powerful learners. And the need for sort of more heavy-handed tuning has really sort of gone down, as the base models seem to be able to learn much faster with far less data, or in some cases, just out of the box. The second part, okay, this is really great. I love this question because I think techniques like RAG are somewhat underused, honestly. Newer models have become much better at using the information provided in the context. I'm reminded of an example, a demonstration that was provided about a year ago, per se, right? Where someone took a grammar manual for this language called Kalamank, which has only fewer than 200 speakers worldwide. They added that to the model in a single prompt, and the model learned to translate from English to Kalamank at a similar level as speakers of that language, which is crazy to think about it, right? There was no fine-tuning, nothing. You just gave it the manual. I think this is an increasingly important capability of models. Techniques like in-context learning really allow the model to solve new complex tasks with just a few demonstrations. And again, this is a very actively growing area of new models as they come about. And like, if anything, I expect performance will keep improving in these areas. RAG is another technique in the same vein, right? Where you can put in a lot of valuable information into the context and hope that the model can learn from those valuable pieces of like the snippets of information that you have provided there. At the end of the day, though, there's also a practical question here. Are you willing to pay the inference cost? Because typically when you have techniques like RAG and context learning, you are working with slightly longer prompts. Again, here too, I feel the pendulum is swinging more towards allowing these techniques, just because techniques like prefix caching and other optimizations of inference mean that LLMs have become a lot better at dealing with such longer contexts. In the older days of transformers, like we no longer in the quadratic attention setting where like you can't scale up to super long sequences. I mean, the Gemini models can handle up to 1 million tokens easily. So I think it then gates on your ability to find useful information. And again, this tends to depend a lot on the actual specific problem and domain. So yeah.
Yep, I love that, and I'm a huge fan of Gemini's long context window, especially for things like pulling in entire code bases. Similar to the example that you gave, I've really loved being able to pull in COBOL code bases along with just kind of an instruction or a documentation manual. And then suddenly Gemini knows COBOL, or it knows COBOL much better than it did before. So if folks are a little bit time crunched and they don't necessarily have the ability to, or the TPU resources or GPU resources to do fine tuning, I think sometimes testing out things in the context window is a really great first kind of prototyping phase, as opposed to starting immediately with fine tuning. Awesome. Next question is our second community question from Unatara. How is data grounding handled when external knowledge bases are real-time data streams? What is the accuracy level for those systems? And Scott, do you want to take a stab at this one?
Yeah, absolutely. So I don't think I have any good metrics that I can share in terms of accuracy levels. I can say that for SecLM, that sort of grounding information is incredibly important for all the reasons Chris mentioned at the very beginning. Just the amount of change that happens in this domain from even hour to hour in terms of, frontline observations of attacks and threats is really important to be able to bring that information in a sort of a real-time fashion. I don't know, maybe others on the call will kind of feel differently here, but like the real-time aspect actually doesn't change much in my mind in terms of how you deal with the data, right? Ultimately, you're still going to want to perform retrieval, right? Which means taking whatever's in the prompt from the user and kind of matching it up against this data somehow, right? So you can imagine caching mechanisms or other data stores that you would sort of update over time as you get the new items in the stream and so on and so forth. I think actually, if I might co-opt this question slightly though, I think one interesting thing to think about here is like specialized versus less or sort of generalized grounding kind of ideas. I think there's an interesting kind of distinction here where you have Google search grounding, which allows you to obviously get a large amount of relatively generalized information about a topic, and then you have a little bit more cost that comes in with like a specialized knowledge base, right? So in SecLM, for instance, we use our internal Mandiant threat intelligence knowledge graph as part of our augmentation. And one of the interesting things here is like sometimes the way in which the cybersecurity community refers to something is like fairly general. So there's a lot of naming for threat actors of things like Cozy Bear or like, I don't know, like Winter Sandstorm. There's a bunch of these kind of a little bit odd actor notions. And if you just go and search these things up on, Google search grounding, you're going to get a whole bunch of really unrelated pieces of grounding information, right? Now, the model usually can sift through these things and kind of identify when it's useful and when it's not useful, but sometimes it can't, and sometimes you get some pretty wacky stuff. So I think one interesting thing to think about here is your kind of domain separation in some ways, where you do have your very well-defined authoritative sources, where you kind of curate it and make sure it's very high quality, and sort of use that as your primary source of information. And then you have something like Google search grounding, which you can use to kind of shore up any gaps that you might have in the underlying knowledge store. I will say one thing that the real-time kind of probably introduces here that maybe I missed a little bit the first part, which is the sort of temporal nature, right? Which is that, you could see many examples of the same entity pass through of this real-time stream with like updated information over time. I think there's an interesting sort of engineering question there about how to integrate that best. But again, to me, this feels a lot like how do you keep your database up to date, or how do you keep replicas of the last iterations of some entities updates in this real-time stream in your database and retrieve them effectively, or at least show it to the model in a way that it kind of captures that temporal change for that model for that entity over time.
I love this discussion about retrieval and kind of augmenting the model's outputs with up-to-date information. And hopefully folks remember back to day 2 where they learned all about vector databases and embeddings and grounding models in data sources. So this is great discussion. Next question. Google Cloud Security uses SecLM technology, which integrates Google SecOps, Google AI infrastructure, and Mandiant's threat intelligence, leveraging TPUs. How do you manage the space complexity? Scott, do you want to take this one?
Yeah, very carefully. Again, I always try to boil things down to like what's existed in the ML space for many years, right? So I think tomorrow is the ML ops session, and I think there'll be a lot more discussion about some of these concepts in that section. But like in my mind, a lot of this complexity eventually boils down to a really, really, really challenging case of ML ops, right? So in a traditional ML system, you have to monitor your data sources to see if there's changes, right? You have to keep your model up to date and do various types of evaluations in both real time and offline to ensure the quality of your model doesn't degrade over time. These same things exist, right? Maybe this time you don't get to choose when the model updates or choose the level of degradation that you can absorb, right? But at least you can monitor all these things. So at the end of the day, it really comes down to like, you know, having these processes, but at a level that's like much more expansive, right? So in the past, if you had like, let's say, an image recognition system, you'd have a stream of new images coming in that you would evaluate against. Maybe you cut off some subset of them to train. Well, here now you're getting, you have all of your input feeds, right? So anything that you're using from a tool or from a RAG store that you have to monitor, which could be many, many sources. For SecLM, for instance, we have, I don't know, at least half a dozen or more different API feeds that we monitor. You have your other sort of static RAG stores. You have Google search grounding. You have the models themselves, which actually, from version to version can demonstrate some pretty substantial behavioral changes. And you basically have to be able to evaluate in an automated fashion, like all of these things, and still be able to actually pinpoint, hey, this thing is degraded on code use cases. This thing is degraded on our threat intel use cases. And then be able to sort of further unravel the sort of knot and say, okay, well, if it's a threat intel, regression, like, okay, was that because the data changed? Was that because the model is not operating the same way on that same data that did in the past? Is there new data that didn't previously exist? Or, another, we talked about the temporal aspect in the last question. That also plays here, right? Which is, yesterday, an IP address or a host name or domain might actually have been considered malicious because at the time it was actually doing malicious things. And in that time between yesterday and today's eval, that might have changed completely, right? That might have been mitigated, or someone may have put some other remediation on it, and now it's no longer malicious. And all these things kind of have to be wrapped up in some holistic eval system so you can kind of really understand what role each component of your system plays and how you can address it to kind of keep high quality.
Amazing. As a distributed systems nerd, this makes me very excited, but also very apprehensive. So this is great. This is great to hear. And it also I think is a lot more sophisticated of an approach than what we saw, even just a couple of years ago when people were first starting to test out these large language models. It's really wonderful to see how models now are just becoming part of a system that's a bit more representative of real world use cases as opposed to just being the end all and be all. So this is wonderful. Thank you for the great question, Deblina Carr. Next question from CX Wong. What are the design considerations on when to apply a domain-specific large language model versus generic LLM in hybrid situations and use cases? Or are there hybrid architectures available that combine both? And we've already touched on this a little bit. Karthik and Eva, do you want to take a stab?
Sure, I guess I can jump in. So yesterday, you heard a lot about agent architecture. So obviously, agent architectures are a great way to combine general and more specialized models into a hybrid solution. If you think where the strengths of a general model are, they're in the conversationalist, kind of the user interface to a deeper system. And then if you have an orchestrator, you can easily have multiple domain-specific LLMs behind that orchestrator, and you can keep those LLMs much smaller and specialized by not even necessarily having the general knowledge, because with Gemini's large context window, the orchestrator can bring in the right domain information, and your generalist conversationalist can actually translate that into a language or a process that's more general. So that's probably the best type of hybrid architecture, is using an agent type of architecture. And this also allows you to bring in data and kind of deploy RAG type of approaches to augment with additional information in real time. So Karthik, do you want to add some?
Yeah, thanks. I think that's a really great answer. So I think the only thing I would add to that is it would depend a little bit on sort of like things like other practical constraints like compute or sort of like the complexity of the system you're targeting. Agentic architectures are really sort of where the world is moving towards per se, but it is not necessarily always like the easiest things for folks to start with. Just quickly play around, get a quick and dirty solution per se. Again, Eva mentioned RAG as well. That's a really nice way of thinking about it. I think it depends a lot on how deep domain knowledge a specific task would need, which could influence the solution. Eva gave an example earlier of sort of if you had medical professionals speaking in their jargon per se, that's not really something which is very easy for us to sort of have a general purpose rather than figure out, okay, this is what is being meant by person A when they're speaking to person B, right? And I think that is, I think, where some of these decisions need to be sort of factoring in sort of like how much deep domain knowledge is needed. But again, I think the hybrid architectures, like as Eva said, like which agentic sort of like the more agentic settings are offering, is really where I see the world moving.
Amazing. Like I think this is wonderful to have these kind of coupled approaches that help real people solve real problems. So thank you both for the excellent answers. The next question is from Batman. So we apparently have a superhero on our Discord channel. With the rapid advancements in large language models for domain-specific applications, what are the key limitations preventing their widespread adoption in critical industries like healthcare and finance, and how can we bridge those gaps? Donnie, do you want to talk about this in the healthcare domain?
Absolutely. My toddler will be very excited to know that I answered a question from Batman today. So I'll talk mostly about healthcare because that's the domain I know the most, but I will say that in the financial services, there's a very strong parallel in terms of financial health and financial data leading to assessments of financial health that are very applicable here as well. So I'll kind of break down the key limitations into three categories. One of them is just the complexity of the domain, which I think Eva has already talked about. And the solutions that she talked about were exactly the things that we actually had to do for MedPal and MedLM, right? To evaluate with expert evaluations. A lot of that had to go into making MedPal and MedLM things that we felt comfortable letting developers have access to. The second layer of complexity is really the complexity of solution. If you think about a health encounter, a clinical encounter, the model prediction is just a very small piece of how that integrates into an entire solution, an entire workflow. And we talked previously about agentic architectures. We haven't really completely solved the problem of what are the right types of architectures or what types of agentic techniques need to be brought to bear in order to solve a system problem or a solution workflow level problem within a healthcare system. And then I think the last layer of complexity is really system-wide complexity. And here it's not just like, even if you have a deployable solution, even if you have like, oh yeah, we can, for this particular use case, we can do the same thing that a doctor does. There are so many stakeholders within the health system, not just regulatory, which Ava also talked about, like healthcare payers, governments, hospital systems, patient advocacy, like a lot of stakeholders need to have their concerns listened to and understood within the framework of that solution. And and making sure that the solution has respects all of these different stakeholders and their needs is also immensely complicated. So thinking about bias, compliance, usability, explainability of the solution, safety, the ability to integrate across a lot of different platforms. So all of those factors come together to really amp up the complexity of the solutions and the needs here. Thanks.
Amazing. And that was our last question for today. Thank you so much to everyone for kind of discussing everything that you're building and everything that you're creating in the research and the production world. I really loved the conversations around agent and hybrid architectures in the medical domains and healthcare, as well as in the security world. It sounds like a really, honestly, very fun and exciting time to be working on these systems. Chris and Scott, did you have anything that you wanted to add about these kind of agent and hybrid architectures?
Yeah, I mean, I think our journey on the SecLM side is probably very similar to the MedLM side, right? I think we learned very, very early on in the process, like whatever 2022 or whenever we started kind of really going down this path. is that, you know, one model probably will not solve it all, right? We can't do the Lord of the Rings here with the model. And so we definitely got to sort of this agentic sort of tool use style architectures very, very quickly, because it does allow us to kind of very pointedly inject kind of exactly the expertise we need in exactly the right places. Right now, I think Paige and others have said that there's definitely like a trade-off here, right? Like you're trading off like the simplicity of just having the one model and doing the one thing and being able to capture that very nicely with eval, with something that's more bespoke and definitely going to have more technical debt associated with it, but it's going to be probably more well-designed to exactly the use cases you want. And I think that's very important when considering the sort of fine-tuning aspect of the LLMs.
Absolutely. So with that, thank you all so much for coming and for sharing everything with us today, and for sharing all of the things that you've built with our over 250,000 of developers out in the world. We really appreciate you. Thank you for taking the time, and we can't wait to kind of test out all of the great products that you've recommended. So have a great rest of your day. And we'll get right into the codelabs, where folks can learn how they can start building all of these experiences and approaches into their own projects. So thank you. And Anant, dive into the notebooks. I'm really excited to learn more.
Thank you, Paige. I'm sharing my screen now. All right, so we had 2 code labs for today, covering a lot of the concepts that were talked about in the white paper and this super interesting discussion, actually. So yeah, let's dive into it. So the first code lab I'm going to be discussing is the one about fine-tuning a custom model. And this code lab, we're going to be just using the same data set, the news group data set from day 2, where we used an embedding model and train the Keras model on top of it. This time around, we'll be using Gemini, both the base Gemini as well as the fine-tuned Gemini for this particular classification task. So the problem remains the same, but we are using a different approach to solve it. So moving on. So in the first part of the code lab, just like in day 2's code lab, we download the newsgroup text data set. And this basically has some newsgroup posts, which need to be classified into their respective newsgroup categories or newsgroups. And you can download this data set, the train and test subsets of it. And yeah, so for example, these are some newsgroups or newsgroup categories, which we expect the model to classify correctly against. So in the next part of the collab, we prepared a data set to both clean the newsgroup posts, which are being fed as the input to the model. However, there is also another aspect to it. The cleaning helps us, or pre-processing helps us prevent the model from shortcutting or directly from the text to the target newsgroup. Because sometimes known users of a forum can be used to guess which newsgroup the text belongs to. So we want to test the ability of the model and its ability to understand the context. So we are removing that additional information from the text. Then after all the pre-processing, it looks something like this, the data frame, where there's text and the respective newsgroups or newsgroup categories. And then now we are going to train parameter efficient fine-tune the Gemini 1.5 model. And in this case, we will keep 50 rows from each category for training. Bear in mind, these 50 rows are significantly less than the amount of rows we used for training the Keras on top of the embeddings in Keras model on top of the embeddings in day 2. That's because the base model already has quite a lot of knowledge embedded into it, and we do not need to use a lot of data to fine-tune it with parameter efficient techniques. So this is what we do here. And then before we get started with tuning and like evaluating the tuned model, it's good to always have a baseline. In this case, our baseline should be as well the base model with just a zero-shot classification approach. So if we just pass in the text, the newsgroup text as an input, it basically gives an answer to the question, or gives an answer to this. Basically, if you give it a text, it does not give you the class. We do not want it to answer to the newsgroup post. We want it to classify it. So here's where your prompt engineering knowledge from day one comes into play, where you give it a prompt like what newsgroup does the following message originate from? And using Gemini 1.1 Flash, we see that it starts giving some newsgroup. It is quite verbose. We just want the newsgroup. We do not want any extra information. So you could also try and parse out the relevant text, or refine it further by giving it some the role prompting, which we learned in day one, and then you see that it gives slightly like more concise responses, but this is not always correct still. So if we evaluate the overall accuracy of across a test set of just using zero-shot prompting for classification, we see it's not very high. And now if we tune, we do parameter efficient fine tuning on Gemini Flash, 1.5 Flash, then we see it improves the results significantly. And there are a few knobs that you can tune, such as epoch count, which tells how many times the model loops through the data, batch size, and more, which you can use to get better results. You need to, just like in predictive models, you need to play around with them to see how much they can improve the performance. Now, so after the new model has been tuned, or the parameter efficient fine-tuned, you see that the performance improves significantly, and that's where we see that in such scenarios, parameter efficient fine-tuning could be useful. Now, as discussed earlier in the Q&A as well, we see that there's another benefit other than performance to doing fine-tuning for models, and that is reducing the token count. So because we do not need a very elaborate prompt at the input side, as well as the model is less verbose on the output end, the model generates and uses less tokens. So the overall token computation is significantly reduced, and that can result in significant token savings, as we see here. So that would be all for this code lab. Let us move on to the second code lab, which I am sharing my screen for. Second. So give me a second. Yes. So I'm sharing my screen for the second code lab, and in this code lab, we look at Google search grounding and how grounding, as we discussed earlier in the Q&A as well, can help you improve performance. Now, the first section of the code lab is an optional one, of course, where you can kind of try out grounding on Google search with the Google AI Studio UI, where you can ask questions and enable grounding to get more up-to-date and more accurate responses. And you can also get citations, so you can see where those answers came from, as well as see which part of the section the response came from, which particular source. And in the second part of the code lab, we do this using API in a programmatic fashion. And here we basically ask, for example, a question about a certain date, when and where is Billie Eilish's next concert, and we see that it does not give you any specific dates because the model is trained up to a point of time and does not have access to real-time information. Now, with grounding enabled, it gives you a specific itinerary of where and when the concerts will happen. Now, another important aspect of the API is that it can provide you not only the response, but also tell you the sources from where the grounding chunks can tell you the sources from where the Google search API provided you the response. So, and not only can it provide you the sources, but you can also go further into it and see which part of the response it can be attributed to which particular source. And this can really help you, as we see in the next part of the collab, it can really help you build this kind of citation augmented response where you know which parts of the response can be attributed to which specific sources. And after that, in the code lab, we learn about using tools together with the Google search grounding tool as well. So other tools, for example, the code generation tool. So in this part, we see that we ask it a question, for example, here, and then we provided the Google search tool, and it provides you an up-to-date, accurate answer by being grounded on the Google search Google search results. But we go a step further where we give it an access to another tool, the code execution tool, which can actually write and execute code for you. And we say, okay, take the results from what you got earlier here and plot this as a Seaborn chart. And we see here that it can generate a very nice chart for you. I personally found this super, super useful. So yes, that concludes our collab, and off to you, Paige, for the pop quiz. Thank you.
Amazing. Thank you so much, Anant. And thank you to Mark McDonald, also who is on our team, who helped build and create all of the code labs that you've been using over the last week. So thank you both so much. With that, we are going to go into the last part of our course today, which is the pop quiz. So for our pop quiz today, you will be tested on all things fine-tuning and domain-specific customization of large language models, starting with what is the primary goal of MedLM in the medical field? Is it A, to replace doctors with AI systems for more efficient patient care? Is it B, to develop AI models capable of diagnosing and treating diseases without human intervention? Is it C, to improve health outcomes by making advanced AI technology available to healthcare professionals? Or is it D, to create a universal AI system that can answer any medical question with 100% accuracy? So grab your pen and paper, or just kind of jot it down somewhere, or take note of it in your head. What is the primary goal of MedLM in the medical field? I'm going to count down 5, 4, 3, 2, 1. And it is C, to improve health outcomes by making advanced AI technology available to healthcare professionals. So keeping a human in the loop and making sure that we get the best quality care to folks. Question number 2, what is the significance of ensemble refinement in MedPalm v2? Is it A, that it allows the model to learn from patient data, B, that it improves the model's ability to generate multiple choice questions, C, that it helps the model identify medical images, or D, that it enhances the model's reasoning and answer refinement by conditioning it on multiple generated reason pathways? What is the significance of ensemble refinement? I'm going to count down 5, 4, 3, 2, 1. And the answer is D. It enhances the model's reasoning and answer refinement by conditioning it on multiple generated reason pathways. Question number 3, what is the innovative approach used by SecLM to address security challenges? Is it A, developing a highly complex AI model with trillions of parameters for superior performance? B, replacing human security analysts with fully autonomous AI agents? C, combining large language models, authoritative data sources, and a flexible planning network? Or D, creating a global database of all known cyber threats for real-time threat detection? Remember back to Scott and Chris's answers and decide what is the innovative approach used by SecLM. I'm going to count down 5, 4, 3, 2, 1. And the answer is C. It combines large language models, authoritative data sources, and a flexible planning network. And as I mentioned, it sounds really, really cool to a distributed systems engineer. Excellent. Question number 4. How does SecLM address the challenge of limited publicly available security data? Is it by A, collecting and storing sensitive user data for central model training? B, by developing specialized LLMs trained on cybersecurity specific content and tasks? C, by relying solely on open source data for model training? Or D, by generating synthetic security data to augment limited public data? I'm going to count down 5, 4, 3, 2, 1. And the answer is B, by developing specialized LLMs trained on cybersecurity specific content and tasks. And with that, thank you so much for everyone who has joined us today. Really appreciate your questions, all of the activity that you've been doing on Discord, and can't wait to see you tomorrow for our last and final day of the Kaggle Generative AI intensive course training. Hopefully you've learned something. I certainly have. And we are really, really grateful to have you as part of this broader learning family all over the world. So thank you. See you tomorrow, and get excited for our last and final day.
Thank you, everyone.
Thank you. Bye.